our guiding question today is, how can we use the knowledge of parachutes that you have right now, okay? And how can we use our knowledge of an atmosphere? And then the whole process, the engineering design process that we've talked about this week, to design a parachute that meets specific criteria for drop speed and parachute size. The first one is, our parachute will need to slow the load, so whatever that load is, in this case it's that clip, it's going to need to slow the load to a drop speed of 5 feet per second or slower. So the second part of this is, though, you're going to need to keep the size of your parachute to a minimum, because our mission to Mars or wherever we're going has limited carrying capacity, meaning it has limited amount of room in the shuttle, and we have a weight thing we have to think about too. So your parachutes have to fit into a certain amount of space on there. So how can we figure this out then? How are we going to figure out if it will fit into a certain amount of space? Kira?
We have to measure it.
We have to measure it? We have to have some sort of way of measuring it, and I'm going to explain to you what you're going to look at, okay? So the first part is you have a score. It's going to be called your parachute packing score, okay? It depends on the size of the canopy and then the length of your suspension line. So you're going to have to do some measuring today and using rulers and all of that. The next thing is your suspension lines. Well, how many lines do you have? 4. And they're all supposed to be the same length. So you measure the length of one of your suspension line in inches, and you need 4 of them. So if your suspension line is 10 inches, 4 times 10 is?
40.
If your suspension line is 20, 4 times 20 is?
680.
80, okay? So then the total packing score then, total means you do what with numbers? No, that's product. You're going to add. So our total parachute packing score says to add your canopy area score. You figured it out here. And your suspension length, yeah. And you get a number. If it's between 30 and 150, if that number comes up to 30 and 150, you're ready to go on this part of it. Okay, that means you could start designing. If it's above 150, you have to redesign. You have to go back and work as a group to try to get that number lowered. So to start off, you're going to be sure to label the materials you're going to use, the size, I just talked about that, and then the length of your lines. And then you're going to say, why do you think your design will work well? Oh, I like what you're doing. Why are you doing that? Why are you dropping that?
To see how good this would work on a parachute. Ah, I got that one. Mine goes very slow. Okay, wait, I want to test them.
Okay, were any of you looking up close at the pieces, the materials too? Because you want to be looking for certain things on the fabric. I saw you testing them out, dropping them from different heights and stuff. You're going to think about everything we've discovered so far about parachutes, and you are independently coming up with a design that you're going to share when you get into a group. So when you get together, you're going to be combining all of your ideas together. And this is what engineers do, is they come up with all these individual imagined ideas, then they come together and they talk about why would it work, why wouldn't it work, okay? So for the next, I'm just going to say 5 minutes. Okay, pencils down, eyes on me. Great designs or creative imagining that's going on out here. People are being really specific with their with the fabrics. So the packet I just gave you has your team's plan, okay? And then you're going to go through the parachute packing score. Once you've come up with this plan, you're going to do the math.
We should do 6 inches of the green. 6 inches. Yeah, 6 inches. You want 6 inches? What do you mean? 6 inches of the green fabric. Okay. Okay. And now we're gonna see the suspension lines. So of a canopy, it will be about 6 inches and stuff. About 6. So 6 times 6, 36.
We're going to look at one team real quick just so you have an idea. They talked about what material they're going to use. They've labeled that. They decided. They talked about that they're going to have a 6, so it's a 6-inch radius. So when they make their circle, it'll be 12 inches all the way across. So the diameter of it would be 12 inches, but the radius is 6 inches, okay? And they're using 8-inch suspension lines. So they figured out their packing score already. And they said, okay, radius of 6. So 6 times 6 was 36. That's their canopy area score. Their suspension line lengths were 8 inches each. So that gave them 32 though. Their packing score was, adding those up, they got a 68. Do they fall inside mission ready? They do. They're going to start to create then if I say that they're ready. So why did you change it?
Because we knew that all of these were big numbers, so that wouldn't add up to a good.
So you knew you'd be out of the mission ready zone when you added them up?
Yeah.
Okay, so then you changed it on here. Did you change it on this picture?
Yep.
Okay, oh yeah, you did. 52, you got 92, you're in the zone. All right, so gather your materials. I don't want anybody sitting back and letting the group work for them. After we get done and we test them, we'll decide on our improve and we'll come back to that. So go to work.
So like you would like go 2.5 right there. So you cut it right. Nope, go right there. Okay, keep it. So 81. So about right there. Wait, we can do the same exact thing with the rest of them, except we can probably cut them all at the same time. You can just measure it like this.
I like the teamwork we've got going on here. You're helping each other, holding tape and stuff. So quietly go stand with your group in line, and then we'll go down there with your materials. So Austin, I'm going to have your group start since you helped me with this morning. Drop. So that was 3 seconds. Trial 2, go. Okay, 2.8. Ready, 1, 2, 3. All right, 2.9. And look at, so they used the plastic canopy, and we'll look at their line lengths and all of that later on. And so we'll do our averages, we'll figure out what your drop was per second. Okay, and then you're gonna get back into your teams then, and you're gonna think about, okay, what are things that we need to change? So I'm gonna have us go back to the classroom. You're gonna put the parachutes in your baskets, and you're gonna sit with your group. Everybody should be opened up to their create packet, their create sheet that shows the designing a parachute. How far did your parachute drop in feet? Everybody dropped about 7 feet. How long did your parachute take to fall? So I'm using their times as an example. You're going to do the same thing in just a second. I have calculators for you to figure this out. We have to figure out the average. And the way that we do that is we're going to add up all of our times. And when I do 8.7 divided by 3, this group gets an average of 2.9. Am I mission ready?
Yeah.
We're mission ready. Could we improve it though?
Yeah.
Okay, so we could make it go slower by 1.4. This is really good though. Turn to this part. This is our last step of the engineering design process. You have worked through the ask step. What's my problem? What have people done? What are the things that could get in the way? What are things we need to think about when we're doing this? You work through the imagine step of it. What are solutions? Brainstorm ideas, creativity, choose the best one. Then you work through the plan, where you actually decided as a team, you drew a diagram, we made a list of the materials that you needed, and you collected your materials. Then you created it and tested it. Now we're going to work on improving it. We're going to make it even better. I love that statement. He's right. If the suspension lines aren't long enough, it's not going to open the canopy enough. It'll be more tight. Nice thinking. And so if you increase the line length, what's that going to do to your canopy?
It's going to make it like open more.
It's going to make it open more. Your words are like music to my ears today.
If we make the parachute top bigger, then more air will get trapped in, so it will like go very slow.
The next thing we need to do then, you've all made some really thoughtful changes. You've got your new design, so now we need to do a new packing score to see if the changes you made keep you in that mission ready spot. Because sometimes we get really eager and we're like, okay, we're going to make a bigger canopy, we're going to do longer lines. Ooh, we forgot that we have criteria that we have to meet. It has to fit the carrying capacity of our space shuttle. Okay, so 4 times 10, 5 times 5, 25. Mission ready by looking here. You are 65. Yep, you're good to go. Put your names on it. All the groups are mission ready from what I've seen. And I want us to think back to the beginning of the week when I read to you the story of Paulo's parachute mission. And this is how it all started. What process did his mom use? Engineering, design, process. And we went through that. They did that process. The aerospace engineers, his mom and dad, they used the process. Well, that's what you guys did all this week. You've been putting all this together, and look at what you've accomplished. Look what you've done. I just want you guys to take your right hand, give yourselves a pat on the back for a very, very great week of learning and putting those brains on, just working together, okay? I read the manual over and over and over again, but nothing makes up for actually teaching it. We've been doing a lot of talk about improve this week. Like, I made an example on the board that was not the best drawing, and so I kind of played around with that and made, like, hey, you can always improve this, and we talk about just anything in life that you can always improve. Just even with my teaching too, I can make improvements. So I think making it that it's not a bad thing to improve, and then just relating it to like things that the kids know from history, that most inventions are, or many inventions are, an improvement off of something that was already done.